In today's complex digital landscape, securing application development from the initial planning stages through to production and ongoing operations is critical. We will cover essential design standards across 5 key phases of secure application development, such as planning and development, committing code, building and testing, going to production, and operating. Let's get on and understand each one of them in detail. Plan and develop phase is where you lay the groundwork for secure application development by incorporating security into the design and coding practices. You plan to achieve several objectives under this phase. Let's discuss each one of them. Threat modeling objective is to identify and evaluate potential security threats early in the design phase itself. You might plan to use frameworks like Stride or Dread to assess risk and design mitigations before coding begins. And you may end up using tools such as Microsoft Threat Modeling. This tool can help visualize threats and defenses. The objective of IDE security plugins is to enhance development environment with real-time security checks. In this case, you as a cybersecurity architect encouraged to integrate security plugins in integrated development environment to detect and prevent insecure code patterns as developer write. Plugins like SonarLint or ESLint can be integrated into popular IDEs like Visual Studio Code to achieve the objective. The objective of pre-commit hooks is to enforce security standards automatically before code is committed to a repository. You as a cybersecurity architect, you promote implementation of pre-commit hooks that run security checks or enforce coding standards before allowing commits. Tools like Husky for Node.js or pre-commit for Python can enforce these checks to achieve objective. The objective of secure coding standard is ensure all developers follow consistent set of guidelines to prevent common vulnerabilities. You as a cybersecurity architect work with development team and train them on secure coding practices such as avoiding hard-coded credentials and validating input. Follow standards like OWASP secure coding practices to achieve the objective. The objective of peer review is to catch security issues through code reviews conducted by peers. You as a cybersecurity architect should ensure that there is a peer review process within the development team. Development team can use pull requests in GitHub or GitLab to facilitate peer reviews to achieve the objective. Commit the code phase involves securing the code as it is committed to the repository. At this stage, we assume that any vulnerabilities are caught in the earlier phase, which we just discussed. Now let's get on and understand each of the objectives that is targeted in this phase. The objective of static application security testing is to detect vulnerabilities in source code before it's compiled or executed. You as a cybersecurity architect ensure that development team have integrated SaaS tools into CI/CD pipeline to automatically scan code for security flaws with every commit. GitHub Advanced Security, SonarQube are some of the popular tools that are mostly used to achieve the objective. The objective of the security unit and functional test is to ensure that individual units of code and their functionality are secure. As a cybersecurity architect, you ensure that development team have written security-focused unit tests to validate that specific security features work as expected as well. Development team can use testing frameworks like NUnit, JUnit, or Mocha with security-focused test cases to achieve the objective. The objective of the dependency management is manage third-party dependencies to ensure they do not introduce vulnerabilities. You as a cybersecurity architect should regularly audit and ensure that dependencies are updated. You use tools to monitor for known vulnerabilities. Tools such as Dependabot for GitHub, White Source, or Sync for dependency scanning can be used to achieve the objective. The objective of secure pipeline is protect the CI/CD pipeline itself from being compromised. You as a cybersecurity architect ensure that CI/CD pipeline is managed with appropriate access control. Secrets consumed in the pipeline are managed, recycled, and maintained securely, and there is an encrypted communication from the Git clients to the actual corporate network. Development team can make use of the Azure pipelines, GitHub Actions with integrated security practices to achieve the objective. In the build and test phase, the application is compiled and tested with a focus on identifying and addressing vulnerabilities in a pre-production environment. Let's understand various objectives of this phase. The objective of dynamic application security testing is identify security vulnerabilities in a running application. You as a cybersecurity architect ensure that development team is using the DAS tool in the staging environment to simulate attacks on the live application. Tools such as OWASP, ZAP, Bubsuit can be used to achieve the objective in this case. The objective of the cloud configuration validation is ensure that cloud resources are configured securely. You as a cybersecurity architect should validate the configuration of cloud services to ensure they meet security standard. You might use cloud native services or you may use third-party services for this case. Microsoft Defender for Cloud and AWS Config are the cloud native services that can be used to achieve the objective. The objective of infrastructure scanning is identify vulnerabilities in the infrastructure supporting the application. You as a cybersecurity architect should ensure that there are processes that scan the infrastructure such as VMs, containers and networks for security issues. Tools such as Microsoft Defender for Cloud, Terraform with security scanning tools can be used to achieve the objective. The objective of security acceptance testing is verify that security requirements are met before going live. As a cybersecurity architect, you should ensure that development team have performed a final round of testing focus on security criteria before approving the application for production. Automated testing frameworks integrated with security tools can be used to achieve the objective. In the go to production phase, when deploying the application to a production environment, additional checks and tests are performed to ensure is secure. Let's understand various objectives of this phase. The objective of the security smoke test is perform quick automated checks to verify that key security features are functioning after deployment. As a cybersecurity architect, you ensure that predefined set of tests focus on critical security aspects like authentication and access control are run and validated for expected outcome. Automated test script in CI/CD pipelines can be used to achieve the objective. The objective of configuration checks is ensure that all security configurations are correctly applied in the production environment. As a cybersecurity architect, you verify security configurations such as firewalls, access control, and encryption settings are in place given the security posture and application functionality. Azure policy, Terraform compliance checks can be used to achieve objective. The objective of live site penetration testing is conduct real world attacks on the live environment to identify and fix vulnerabilities. As a cybersecurity architect, you engage with penetration testing team and simulate attacks in the production environment. Azure penetration testing guidance, commercial pen testing tools can be used to achieve the objectives. In the operate phase, once the application is live, continuous security monitoring and response are critical to maintaining its security postures. Let's understand various objectives of this phase. The objective of continuous monitoring is constantly monitor the application and infrastructure for security threats and anomalies. As a cybersecurity architect, you implement real-time logging, alerting, and monitoring solutions to detect and respond to security incidents. Azure Monitor, Microsoft Sentinel for SIEM tools can be used to achieve the objective. The objective of threat intelligence is stay informed about emerging threats that could impact the application. As a cybersecurity architect, you should integrate threat intelligence feeds into your security operation to anticipate and defend against new attacks. Microsoft Defender threat intelligence can be used to achieve the objective. The objective of penetration testing is periodically test the live application for vulnerabilities that may have been introduced after deployment. As a cybersecurity architect, you schedule regular penetration tests to identify and remediate security issues. Use third-party or internal pen testing tools to achieve the objective. The objective of the blameless postmortems is analyze security incidents to learn from them without placing blame on individuals. As a cybersecurity architect, conduct postmortem meetings to review what happened, why it happened, and how to prevent it in the future. Incident tracking and reporting tools integrated with project management systems can be used to achieve the objective. So now we have sufficient understanding of each phase in the secure development lifecycle. And you know now what to expect during the planning, building, testing, moving to production, and the sustainment stage. The DevOps processes that are outlined in the Microsoft Cloud Security Benchmark is comprehensive. Though tools or services reference can be used based on the organizational practices, still those examples provide you solid understanding. By following these design standards, organization can build and maintain secure applications that are resilient to both current and emerging threats. If you're particularly working in the Microsoft ecosystem, leveraging tools and practices from the Azure and Microsoft ecosystem, teams can ensure that security is integrated throughout the entire software development lifecycle.